Obtaining an expression for dy dx. This is where you'd realize you just need to differentiate this, but differentiating this involves what? You can tell that this is not an acceptable format. You know what it needs to look like for easy differentiation to happen, which is number times something x to the power of another number. So without further ado, over here you realize this has to be rewritten into the acceptable format, which is, this is the same thing as what? Tell me. You would rewrite this into this format over here, and then now you differentiate dy dx, which is going to be -1 times this, times the whole thing by 2. This doesn't have a relationship with x, does it? Dy dx of that just becomes 0. And that's where we get our first answer. Dy dx is just going to be -1 times 3, and times the whole thing by 1 extra step, which is times by 2. This is the basics of differentiation over here, as I'm sure you recall. And that's where we get the derivative over here for dy dx. Explain why this curve has no stationary points. If you think about this question too directly right now, it might not be obvious. Instead, just think about it this way, okay? If you want to find, first off also, 1 mark, you're aware that if it's only worth 1 mark, it's nothing crazy. Don't need to do anything extremely elaborate over here, just one statement is enough. So what you realize over here is they're testing you on no stationary points. How does it not have stationary points? Well, how do stationary points always happen? It's always going to be dy dx equals to 0, isn't it? I'm explaining to you what they're really testing you on here. You're expected to think, oh well, dy dx equals 0. That's how we would find the stationary point if it did have one. So in order for it not to have one, doesn't that just mean dy dx equals 0? Doesn't work. If you're not sure about how that is, check it out. Do dy dx equals 0. See what happens. You'll see that if you make dy dx equals to 0 over here, it just means the same thing as the previous part we differentiated gives you -6 bracket 2x minus 1 to the power of -2. I'm sure you understand why this has to be rewritten into this format over here to make it more obvious if you were to solve it for 0. Make it equal to 0, and you understand how this becomes this, doesn't it? Because anything to the power of -2 is just the same thing as to the power of 2, just do 1 divided by -6 times 1 divided by 2x minus 1 to the power of 2. I'm sure you understand how that becomes -6 over 2x minus 1 to the power of 2, like this. As in, you know to rewrite this into the fraction format if you're trying to do solving it equals to 0. And if this is how you would find the stationary point, you realize this has no solution, does it? Because it means the bottom has to be what? Like if you multiply this other side, you end up with -6 equals 0. It's a math error. So the best way to describe it is just says no stationary points because dy dx equals to 0 doesn't have a solution. That perfectly encapsulates the scenario over here, doesn't it? You've got a scenario here where this can't be solved, so that's why you say it has no solution. So if dy dx equals to 0 can't be solved, if it doesn't have a solution, you made that clear, then there's not going to be a stationary point, is it? See why this perfectly explains why the curve doesn't have a stationary points? At the point P on the curve x equals to 2. Okay, good. Show the normal passes through the origin. Showing that the normal passes through the origin. Take a look at this. If we're trying to say that at P x equals to 2, doesn't that mean the normal over here, we realize what has to happen before the normal? It has to be the tangent. See how that works? So let's find the gradient of the tangent first. The gradient of tangent is just going to be dy dx, substitute 2 into there. Does that make sense to you? dy dx, substitute 2 to find the gradient at P, which is -2 over 3. The gradient of the normal then is going to be -1 divided by that, which is 3 over 2. So if you're going to prove that the normal goes for the origin, find the equation of the normal is my point. You see what we're doing over here? We're finding the equation of the normal first. We realize the normal is just a straight line. The straight line just needs an example of points and the gradient of that straight line, which is y minus y1 equals to m bracket x minus x1 formula, isn't it? That's what we've done over here. We found the gradient at P and then found the normal gradient at P. So we just do y minus y1 equals to m bracket x minus x1. So we just substitute that in for m. And then do we have the coordinate for P? Because P is the only point we know the line goes through, doesn't it? 2, 3. Where do we get that from? Well, substituting 2 into what? That's the equation for y, isn't it? That's how you use the equation of the curve. Doesn't matter what the equation of the curve is. The whole point of it is to find examples of coordinates on there. If telling you at P x equals to 2, you're guaranteed to find what y is equal to then, isn't it? And that's how we get an example of a coordinate that the normal has to go through. And that's how we found the equation of the normal over here. Because the gradient of the normal that we found over here, and using y minus y1 equals to x bracket minus x1, we found this is the equation. How do we prove it goes for the origin? Well, what is the origin? The origin is 0, 0. When x is 0 and y equals to 0, doesn't that mean it goes through the origin? Think about the definition. If you have a straight line that goes through the origin, it means what? You're guaranteed to make sure that if x is equal to 0, y has to be equal to 0 for the equation of that line. If this is the equation of the line we found, yes, prove it. When x equals 0, y indeed is equal to 0, isn't it? So therefore, we prove that it passes through the origin over here. This is a very comprehensive explanation, isn't it? Very simple, but it perfectly explains why it does indeed go for the origin. So over here, you have dy dx, you've already got that assembled. Dx dt, you've already got that assembled. And you realize dy dt, which is what they're asking you to find, because they want you to find the rate of change of y coordinates. It just means dy dt, doesn't it? Because anything divided by dt, anything over time, anything over dt is just going to be rate of change. So rate of change of y coordinate, you know it's going to be dy dt. And you know algebraically, it's the same thing as what? dy over dt is the same thing as dy over dx times dx over dt. You understand how that simplifies into dy over dt, doesn't it? We already know what dy dx is. It's this. We already know what dx dt is. It's this. So it just means substitute 2 into there. Because they're saying at the point P, which is what we want to find, well, we know at P, x equals to 2. So it's just the instruction of x equals to 2 we substitute into there to find the dy dt at x equals to 2, which is the same thing as dy over dt at point P.